Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. In an astonishing revelation that has sent shockwaves through the scientific community, NASA confirmed that Voyager 1, humanity's greatest distance and longest-lived spacecraft, has made an impossible discovery after 45 years of traversing the universe. Launched in 1977 to explore the outer planets, Voyager 1 has now ventured into interstellar space more than 14 billion miles from Earth. This latest finding, however, defies our current understanding of physics and space exploration, hinting at phenomena that challenge the very fabric of our scientific knowledge. What exactly did Voyager 1 discover that is considered impossible? Join us as we unravel the impossible discovery NASA confirmed about Voyager 1 after 45 years in space. Our Earth, with its expansive oceans and towering mountains, is merely a tiny spot in the vast expanse of the universe. Philosophers have contemplated this for centuries. However, it wasn't until the 1970s that NASA scientists gained a true understanding of the cosmic scale. This revelation began with an accidental alignment of Jupiter, Saturn, Uranus, and Neptune, the four largest planets in our solar system. Amidst this celestial choreography, Gary Flandreau, a young PhD student working part-time at NASA's Jet Propulsion Laboratory while studying at the California Institute of Technology, made an astonishing discovery through careful calculations and charting of the giant planets' orbital paths. He unveiled a remarkable truth in the late 1970s and early 1980s. Flandreau made a groundbreaking discovery in space exploration, a celestial phenomenon that would revolutionize our understanding of planetary alignments. What Flandreau uncovered was truly breathtaking. For planets aligning in a mesmerizing formation resembling pearls on a cosmic necklace, with Earth nestled among them. This discovery sparked unparalleled excitement at NASA, offering an unprecedented opportunity to revolutionize space travel. By strategically utilizing the gravitational pull of each planet during flybys, a spacecraft could achieve a remarkable speed boost, similar to being guided by an invisible cosmic force that propels it forward. Flandreau's calculations indicated that these gravity assists from the giant planets could drastically reduce the flight time from Earth to Neptune. What was once a formidable 30-year journey could potentially be completed in just 12 years thanks to these cosmic maneuvers. This revelation opened new doors for optimizing space missions and exploring distant realms within our solar system. In a stroke of cosmic coincidence, NASA's ambitious mission capitalized on a celestial event known as a planetary alignment, a phenomenon that occurs once every 176 years. This rare alignment, where the planets of our solar system fall into a perfect arrangement, presented an unprecedented opportunity for exploration. NASA's decision to launch Voyager 1 and Voyager 2 within a mere 15 days of each other in the summer of 1977 marked a milestone in space exploration. These twin spacecraft were marvels of engineering, equipped with cutting-edge instruments designed to unravel the mysteries of our solar system and beyond. Their mission was not only to explore the outer reaches of our planetary neighborhood, but also to venture into the uncharted territory of interstellar space. Each Voyager spacecraft carried a golden record, a time capsule of humanity's achievements and cultural diversity intended to communicate our existence to any extraterrestrial beings that might encounter it in the distant future. This symbolic gesture underscored the impressiveness and ambition of NASA's endeavor, transcending mere scientific exploration to embody a profound quest for knowledge and connection across the cosmos. On September 5, 1977, Voyager 1 embarked on a monumental journey as part of the Voyager space program, embodying humanity's relentless thirst for knowledge. For nearly 5 decades, this fearless explorer has pushed forward, transmitting invaluable data back to Earth via NASA's Deep Space Network. It serves as a lookout in the vast expanse of the cosmos, bridging the gap between our terrestrial lives and the mystery that waits beyond. Voyager 1's mission was initially designed to last only 5 years, focusing on the exploration of Jupiter and Saturn. However, it far exceeded expectations, providing humanity with stunning images and groundbreaking discoveries, such as the detailed photos of Jupiter's Great Red Spot and the intricate structure of Saturn's rings. Voyager 1 also discovered active volcanoes on Jupiter's moon Io and intricate patterns in Saturn's rings, which revolutionized our understanding of the outer planets and their moons. As of August 2023, this spacecraft rests an astonishing 24 billion kilometers away from Earth, marking it as the most distant human-made object from our planet. Painstakingly crafted by the brilliant minds at NASA's Jet Propulsion Laboratory, Voyager 1 embarked on its historic voyage from Launch Complex 41 at Cape Canaveral Air Force Station, propelled by a Titan IIIe launch vehicle. Voyager 1 carries a golden record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. This record includes 115 images, a variety of natural sounds such as thunder and birdsong, musical selections from different cultures and eras, and spoken greetings in 55 languages, along with printed messages from then U.S. President Jimmy Carter and then UN Secretary-General Kurt Waldheim. In 2012, Voyager 1 crossed the outer edge, the boundary where the solar wind from our sun is stopped by the interstellar medium, making it the first human-made object to enter interstellar space. This monumental achievement provided scientists with invaluable data about this previously unexplored region. Just when one might think they've seen everything, recent revelations continue to unfold. For instance, in 2021, Voyager 1 detected a persistent murmur of interstellar gas, a groundbreaking discovery that offers new insights into the density of interstellar space. As Voyager 1 continues its journey, it carries with it our hopes and dreams, venturing ever deeper into the cosmos where countless more mysteries wait. Delving into the amazing journey that led to the discovery of 500 previously unknown objects drifting through space and the fascinating insight shared by Joe Rogan in a recent episode of The Joe Rogan Experience, imagine a man-made spacecraft boldly exploring the unknown and overcoming the immense challenges of deep space for decades. That's Voyager 1 for you. This courageous spacecraft has already traveled an astonishing 14.5 billion miles from Earth. To put that in perspective, it's like covering a distance about 3.6 times the span between Earth and the Sun every single year. Voyager 1 isn't just remarkable for its speed, longevity, and the vast distance it has covered. It has also provided us with groundbreaking discoveries, including the recent identification of 500 previously unknown objects in the far reaches of space. These celestial entities are unlike anything we've ever encountered or identified before. It's a cosmic treasure trove filled with mysterious wonders, and we're about to delve into the fascinating details of this inspiring revelation. You might be wondering how a spacecraft launched back in 1977 is still functioning and delivering such astonishing results. Behind Voyager 1's design, one of the key factors contributing to its longevity is the presence of dual redundant computer systems. Both Voyager 1 and its twin, Voyager 2, were equipped with two sets of command computer subsystems, the Flight Data Subsystems, FDS, and the Altitude and Articulation Control Subsystems, AACS. This abundance was a brilliant innovation, ensuring seamless transitions between systems and enabling the activation of dormant computer components when necessary to extend their lifespan. The computer systems aboard the Voyager spacecraft were ingeniously designed as a distributed system featuring 3 pairs of dual redundant computers. This clever setup ensured that if one system failed, another could seamlessly take over, preventing any critical mission failures. To make the most efficient use of their limited power resources, the Voyager instruments relied on hardwired circuits. These simplified circuits were specifically designed to operate within strict power budgets and time constraints. During the spacecraft's development, power management was a crucial element for maintaining the operational integrity of Voyager 1. The spacecraft's vast distance from the Sun makes it challenging to tackle solar energy, making power efficiency a top priority. Engineers had to invent creative ways to save and optimize power usage, and their methods are truly amazing. One key strategy involves selectively shutting down non-essential systems to manage power. Engineers carefully determine which components or subsystems aren't crucial for the main mission objectives. For instance, heaters linked to certain scientific instruments have been turned off. These heaters were originally meant to keep the instruments at specific temperatures for optimal performance, but turning them off greatly reduces power consumption, thereby extending the spacecraft's overall lifespan. Moreover, engineers employ advanced algorithms to monitor and predict power usage patterns. These algorithms can forecast the power needs of different subsystems and adjust their operation in real time, ensuring maximum efficiency. They also use state-of-the-art materials with high thermal insulation properties to minimize heat loss, further conserving power. Another fascinating aspect is the use of energy harvesting technologies. The spacecraft is equipped with devices that convert atmospheric energy, such as temperature differences and vibrations, into electrical power. This supplemental energy source, although small, contributes to the overall power budget, allowing the spacecraft to operate longer than initially planned. However, don't think that the decision to power down non-essential systems is made lightly. Each shutdown is carefully planned and tested in simulations to ensure that it won't compromise the mission. The engineers also have contingency plans in place to quickly reactivate any system if the mission parameters change or if unexpected issues arise. These power management strategies not only extend the spacecraft's operational life, but also push the boundaries of what is possible in space exploration. The process involves carefully weighing the benefits of saving power against the scientific goals of the mission. Engineers and scientists work closely together to ensure that turning off certain systems doesn't hurt the quality or availability of the scientific data collected. The aim is to find a perfect balance that maximizes power efficiency while keeping all essential functions running. Interestingly, Voyager 1's power management strategies are flexible and adjust to the changing conditions of space. As the spacecraft travels farther from the Sun, the amount of solar energy it receives drops. Voyager 1 adapts its power usage to match these changes, ensuring that the available resources are used wisely to support crucial operations and data transmission. No matter how far it goes, it's like a smart energy-saving mode that automatically activates. Over the years, there have been incredible advancements in technology and improvements in how we manage power. Engineers have carefully refined and optimized the power systems of the Voyager probes, implementing upgrades such as better power distribution, improved battery charging methods, and advanced power regulation and control. Thanks to these careful power management strategies, Voyager 1 has exceeded all expectations. It continues to send back valuable information nearly 50 years after its launch. Considering that this space traveler was originally designed to last just 5 years, its ongoing mission is truly remarkable. This achievement highlights the dedication and skill of the scientists and engineers who have worked tirelessly to keep Voyager 1 operational. The Voyager missions, designed to explore the far reaches of our solar system and beyond, were outfitted with an impressive array of scientific instruments and subsystems. These instruments were carefully positioned on the spacecraft, which were composed of an astounding 65,000 individual parts. When the Voyagers embarked on their interstellar journey in 1977, they carried a golden record containing sounds and images from Earth intended to communicate the story of our world to any extraterrestrial life that might encounter them. Initially, both spacecraft were only expected to last 5 years, but they have far exceeded their expected lifespans, continuing to send valuable data back to Earth for over 4 decades. Today, only 4 of these instruments remain operational on Voyager 1, and 5 continue to work on Voyager 2. Among the enduring instruments on both spacecraft is the low-energy charged particle detector. This remarkable device has 3 sets of particle sensors that measure the number and speed of low-energy particles striking it. These measurements have provided crucial insights into the region, the vast bubble of charged particles that the Sun blows around itself, and the boundary where it meets interstellar space. Voyager 1 entered interstellar space in August 2012, becoming the first human-made object to do so, while Voyager 2 followed in November 2018. As they travel through this uncharted territory, they continue to relay groundbreaking information about cosmic rays, magnetic fields, and the density of interstellar plasma. Their journey has revolutionized our understanding of the outer solar system and the space beyond, offering a glimpse into the mysteries that lie in the deep, dark reaches of our galaxy. The spacecraft carefully monitor cosmic radiation and particles coming from the Sun, the planets, and outer space. Another tool, the Cosmic Ray Instrument, actively searches for high-energy particles from both the Sun and other parts of the galaxy. Right now, this Cosmic Ray Instrument is busy detecting the number of particles within the protective bubble created by the Sun's influence, as well as particles coming from the vast reaches of interstellar space. These readings have been crucial in identifying when Voyager 1 crossed into interstellar space. Amazingly, this instrument is still working on both Voyager 1 and Voyager 2. The plasma wave subsystem, which has two long antennas set at right angles to each other, is a vital tool for measuring the electrical field components of plasma waves encountered around the outer planets. The role of this instrument has changed as the Voyager spacecraft ventured into interstellar space. Today, it gives us valuable insights into how plasma waves behave as they move into this vast and mysterious region. Remarkably, it still operates on both Voyager 1 and Voyager 2. Originally, the magnetometer was designed to study the magnetic fields of the outer planets. Now, it plays a crucial part in finding the transition zone between our solar system and interstellar space. Scientists use it to examine the magnetic features of this boundary area, where the sun's magnetic influence meets and merges with the magnetic field of interstellar space. It's impressive that this magnetometer remains functional on both Voyager 1 and Voyager 2, continuing to help us explore the unknown. Another important tool is the plasma science instrument, which carefully studies the lowest energy particles in the plasma. It can identify particles moving at specific speeds and, to some extent, trace their origins. These abilities become even more important as the spacecraft travels deeper into interstellar space. However, it's important to note that this instrument is only working on Voyager 2. Some instruments on the Voyager spacecraft have stopped working, either on their own or have been turned off intentionally to save power. The plasma science instrument on Voyager 2 continues to be a vital part of our scientific exploration. Additionally, to save energy, NASA systematically turned off heaters on both spacecraft in 1998 after 21 years of operation. Non-essential instruments have been permanently powered down on each spacecraft, which rely on 3 radioisotope thermoelectric generators, RTGs. These generators use the heat generated from the decay of plutonium-238 to produce electricity. However, as plutonium-238 continues to decay, it will eventually be unable to provide sufficient power, leading to the termination of all instrumentation. This decline is expected around 2025. Despite this, the Voyager team is employing careful power management techniques to extend the operational lifespan of both spacecraft until 2027, coinciding with the 50th anniversary of their launch. Each Voyager probe is equipped with a pair of thrusters, not for propulsion but to reposition the spacecraft so that its antenna remains consistently pointed toward Earth. This alignment is crucial for maintaining communication. The thrusters emit brief pulses or puffs lasting milliseconds to gently rotate the spacecraft and orient its antenna towards Earth. In November 2017, due to the deterioration of Voyager 1's primary thrusters, scientists successfully activated the backup thrusters after nearly 4 decades of dormancy. Through this action, Voyager 1 managed to maintain its connection with Earth, a remarkable feat despite long periods of dormancy. The backup thrusters activated successfully, reorienting the spacecraft's antenna. The Voyager probe's primary transmitter emits about 20 watts of power, equivalent to the light of a standard refrigerator bulb. By the time Voyager's signal reaches Earth, its strength has diminished to a staggering 20 billion times weaker than that of a digital watch battery. It's fascinating to consider that your iPhone has memory capacity 100,000 times greater than that of the Voyager spacecraft. Despite its advanced technology at launch, the spacecraft Voyager 1 has now become central to understanding its missions. Recently, there are mysteries surrounding Voyager 1. There are more than 500 unidentified objects in space. Could Voyager 1's data transmission be a glitch? Has it malfunctioned before? Voyager 1 has captured the scientific community's attention with its latest find. The probe has stumbled upon an extraordinary discovery: 500 unknown objects lurking in deep space. This revelation has sparked concern among researchers as these mysterious objects remain largely enigmatic. Adding to the intrigue is the initial data sent back to Earth, a chaotic jumble resembling a complicated message from the cosmos itself. Imagine the sheer surprise carved across the faces of NASA scientists at the Jet Propulsion Laboratory when they first intercepted these baffling signals from the deepest corners of space. After careful inspection, they pinpointed the root of the mystery to Voyager 1's crucial attitude articulation and control system, AACS. This indispensable component aboard the spacecraft is tasked with measuring, communicating, and fine-tuning its dimensional orientation. Equipped with an antenna aimed back at Earth, the AACS serves as the lifeline for transmitting invaluable data home. Upon investigation, scientists unearthed a startling revelation. The AACS had unexpectedly switched to a long-dormant, malfunctioning onboard computer. This glitch had rendered the telemetry data skewed, perplexing NASA's experts. Swiftly, NASA engineers mobilized to rectify the irregularity, reconfiguring the use of onboard systems to address the malfunction and restore accurate data transmission.